Hello everyone, and welcome back to the AI Research Roundup. I'm your host, Alex. Today we're diving into a really interesting paper called OmniCaptioner, one captioner to rule them all. So what the researchers propose here is basically a single versatile framework called OmniCaptioner. It's designed to generate really detailed text descriptions, captions for all sorts of visual stuff. Unlike older methods that might only work well for, say, regular photos, this one aims to be a unified solution, handling a much wider variety of visual domains right out of the box. So, Figure 1 here really gives a good visual overview of this. The top part shows exactly what I meant by diverse visual domains. You see examples like regular photos, math problems, tables, charts, even user interfaces, posters, PDFs, and video frames. And for each type, OmniCaptioner can generate different kinds of descriptions, like detailed captions, short ones, or even specific formats like LaTeX for math or Markdown for charts. Then, the bottom part highlights its main uses, boosting visual reasoning when paired with LLMs, making text-to-image generation better, and allowing for more efficient fine-tuning on specific tasks. So building on that overview, Figure 3 really dives into some specific examples of those applications we just mentioned. It shows how OmniCaptioner's detailed captions help LLMs perform complex visual reasoning, like with that geometry problem. And it contrasts this with another model, LLAVA1 Vision, showing how OmniCaptioner's captions can lead to better text-to-image results and avoid issues, especially when dealing with non-natural images like charts or web pages, where other models might struggle. So building on those examples from Figure 3, Figure 2 here really gives us the hard numbers, backing up those claims about enhanced reasoning. It's a bar chart comparing different setups on benchmarks like MME, MMMU, MathVision, and MathVerse. The key thing is comparing the OmniCaptioner plus LLM combinations, those solid, patterned bars, against baselines like QN2VL which is the dashed bar. And you can see, OmniCaptioner consistently boosts performance across the board, often by quite a bit. This shows how feeding the LLM a good caption works really well. So we saw the performance boost in Figure 2. Now Figure 4 here shows us how they actually created the massive dataset behind OmniCaptioner. It's a three-step pipeline. First, they collected a huge 21 million item dataset covering all those different visual domains we saw earlier, much more diverse than older datasets. Then, they generated initial seed captions using different methods like GPT-4o or rule-based approaches depending on the image type. And finally, they expanded on these captions, adding different lengths, translations, and even reasoning steps to make the training data really rich and varied. So after creating that rich dataset we saw in Figure 4, Table 1 here shows the payoff. It compares how well different LLMs perform on visual tasks when they use captions from OmniCaptioner versus other state-of-the-art multimodal models across benchmarks like MME, MMMU, and especially those math ones, MathVision and MathVerse. You can see the OmniCaptioner combinations, those highlighted rows. They consistently achieve really strong scores, often beating comparable models. For instance, look at the 7B models on MathVision. OmniCaptioner plus DSR1 Distill QN gets 36.2, much higher than the baseline QN2 VL7B's 16.3. It really shows how just providing a better caption significantly boosts the reasoning ability, even without extra training for the LLM itself. So Table 1 showed how OmniCaptioner captions help LLMs reason better. Now, Table 2 here looks at a different angle, how these captions can improve text-to-image generation. This table compares a specific image generation model, SANA 1.0, when it's fine-tuned using captions from different sources. The benchmark is called Genival, and you can see, when fine-tuned with OmniCaptioner's captions, that bottom row, it gets the best overall score, 67.58, beating the original model and the one trained with QVL captions. So better captions seem to really help generate better images too. So we've seen how OmniCaptioner improves LLM reasoning in Table 1 and text-to-image generation in Table 2. Figure 5 here gives us another look at that reasoning enhancement. It specifically shows what happens when you integrate OmniCaptioner with different versions of the Quen series of LLMs, from older ones to newer ones. The blue bars are scores on the MMMU benchmark, and the red bars are for MathVerse. You can clearly see, well, as the underlying LLM gets more capable, moving from left to right, the performance on both benchmarks gets significantly better. It really highlights how OmniCaptioner synergizes with these models, enabling them to tackle complex multimodal tasks more effectively. So yeah, looking across all these results, it really underscores the power of OmniCaptioner. It's not just about making any caption, it's about making really detailed, accurate ones, especially for complex stuff like math diagrams. And we saw how that directly translates to better reasoning in LLMs and even better image generation. It really highlights how crucial high-quality descriptions are for, well, bridging that gap between vision and language effectively. Well, that's all for this episode of the AI Research Roundup. Thanks for tuning in. I'm your host, Alex.